thing. It means a restricted angle.
How do we know when to put it in degrees versus
You're just probably always going to give you radians. I'm just a radian person.
I got it. Radian means happy.
And
No. Oh, wait, that wasn't it.
angle whose sine is, and when we ask for this, this is always going to be a restricted angle. So the first thing that you need to remember is, where is sine restricted? What quadrants? 1 and 4. The domain goes from negative pi over 2 to positive pi over 2. So if you start out like this, this is a good way to start. Now, where is sine positive? In 1. I don't want this one. So label your triangle and find me your angle. Right? And you can confirm it on your calculator, but you can't do them on your calculator. I need to see where they exist. This is the same as asking arc cosine. Where is an angle whose cosine is -1? Well, if I think of the cosine curve, and I go to restrict my cosine curve, well, notice I cut it off here where cosine is 1 at 0. When I come down where cosine is -1, what angle is that? I went past the 90, 180. And again, if I did all my quadrants, I go from here to here. The 1 and the 0 for sines and cosines are at your quadrantal angles, not tangent. Because this is where, remember, our mins and our maxes and our zeros all came from your quadrants. Tangent is different. Tangent, it has no limit to tangent. So that's not going to be at a quadrant angle. You're only going to find your zeros there. Okay, so what restricted angle has a cosine of -1 from quadrants 1 to quadrant 2? That would be my 180. And yeah, I didn't say that you had to answer in degrees, but, radians. So if you answered in degrees, that's fine. I'll try to remember, because usually we just do radians by the time we hit pre-calc. Okay, stop me if you're having any questions. Now, tangent is the one. If you visualize your curves, visualize your tangent curve, because this is where your domain comes from. Oh, so if this is 1, 2, 3, I need to know what angle had a 1. What angle has a tangent of 1? 45. Isn't that one of your special triangles? 1, 1, radical 2, or tangent, y over x. All your functions are positive in quadrant 1. So whenever they give you a restricted domain, I don't even care where it is. If it's positive, it's got to be in quadrant 1. Just drop your triangle in quadrant 1. It's the negative that you got a little thinking. The sine and the tangent are negative in 4, and the cosine is negative in 2. So what angle is this guy? 45. Pi over 4. I'm 1 and 4. Everybody's positive in 1. Good? Stop me if you have any questions. Okay, this guy says, I have an angle whose cosine is 0. Well, when I think back to my cosine curve, and I cut it off here, and I pass by, oops, this has a 0. What angle is this halfway between 0 and 180? Pi over 2. Isn't that a 90?
Yes.
Right? Isn't that my 90? If you draw your curves out like this, your actual graphs, I think it makes more sense. The zeros and the ones for sine and cosine come off your quadrant angles. So again, 0 is the x value for cosine. So that would be your pi over 2, your 90. But if you kind of visualize where you're going with this, well, there's your sine of 0 at 1. I'm sorry, your cosine of 0 at 1. Your cosine of pi. at -1. There's your 0 at pi over 2. Yes.
So when it says like the cosine of like the 1 or the 0, you just draw the curve and then where it is?
Yeah. Find me your 1 and your 0. If I say arc cosine of -1. So if I draw my curve out, isn't these the pieces that you know that we do? Like that gives us your max, your mins, and your zeros. So where is this guy? Oh, if I just draw my curve out, I start here, I end here. There's my pi, right? Okay. So then we have an arc sine of 0. So visualize your sine curve. Wow, where does it start? Where does your sine curve start? At the 0. Isn't the sine of 0, 0? And when I do this, I have to cut this off here and here from -90 to +90. But where is sine 0? At the 0. Right? Where is sine 1? What's this value where we cut it off? 90. Where is sine -1? At the -90. Aren't those your mins, your maxes, and your zeros? The zeros and the ones? Right? So to me, I think it helps visualizing the curve. And do your quadrantal angles, that's absolutely fine. I could say sine goes from 1 to 4. So lay these pieces out. Sine is my y value. Which y value has a 0? Oh, there it is. At the 0. There's a number of ways you can find these. Okay. And the last guy, arctan. Tan is positive in 1 and negative in what quadrant? 4. It goes from -90 to +90, just like your sine does. It's just that we don't have a tangent for the 90 or -90. So I drop my triangle in quadrant 4, not in quadrant 2, because I'm only restricted right here. So this is positive, this is negative. I say y over r, I know this is a 30-degree angle, and I've got to be from -pi over 2 to +pi over 2. So I've got to have a negative angle right here. This has to be -30 or -pi over 6. It cannot be 330, because that's out of my domain for my restricted tangent. Good? Questions on any of these? Coming back to you? After a 2-day weekend? All right. All right, so let's look at our compositions. So our compositions say we're always going to start at the right. Okay, so arctan says find me an angle whose tangent is -5. Restricted, right? I know I have a restricted angle. And so let's find out first, where is tangent restricted? 1 and 4. So out of 1 and 4, where is it negative? 4. So I drop a triangle in 4. Now, tangent is y over x. So this is 5 and 1. And I've got to find this angle. However, I locate this spot, and then I move to the right. I know where this is going to be. And out of this mess, all I need to find now is what is the tangent of that angle. So ultimately, I don't need to know the angle. I need to find its location, then see, okay, what do they want me to do with this guy? Now I need to find the tangent of this. So what's the tangent of this triangle? -5. Isn't it -5 over 1? Same thing. Isn't it the same thing?
Yeah, that's why can't you just cancel
Can't you cancel it out? Yes. Yes. So I need a tangent of an angle. So this is what I wanted to do with you first. The tangent of an angle whose tangent is. So see what it's saying to me? Find me the tangent of an angle whose tangent is -5. Do I care what the angle is? All I want to do is find what? The tangent. So in this case, couldn't I just cancel that out and say -5? Yes. But if I'm looking at it logically, doesn't it work the same way that it's supposed to work? Don't I locate this guy? This is my restricted part. And then I take the tangent. Now, what if instead, what if instead this said sine? Find me the sine of a restricted angle whose tangent is -5. I'd have to find the radius. So I'd have to say 5 squared plus 1 squared equals r squared, so 26. I would have to see if I could break this down, and I can't. So now I would find its sine. Sine is y over r. If I wanted the sine of this, if I just wanted the tangent of this, I already know what the tangent is, right? But I can still locate my triangle, figure out which part I need, and work from there. Okay, so that was just a little bit tricky, but I like this example because it kind of makes sense what we're looking for.
So wait, why did you find the sign of that one?
Oh, I just said what if it didn't say tangent. Because tangent means I can just cross it out, but I did want you to find where it is. And so say it said what the sine of this or the cosine of this. Then I located it, find the missing part, and find whatever they asked of me. Okay. Now, let's take a look at this. This piece only. I start at the right. This is my first part. What are they asking me to find? So they want me to find the sine of 5 pi over 3. Is there any restriction here at all? No. So I am going to find 5 pi over 3. What quadrant is 5 pi over 3? So I know this is 3 pi over 3. I know this is doubled. So where does 5 pi over 3 come out? 4. So I come all the way around here. Right before the 6, I get the 5. And how many times does 3 go into 180? 60. So I label my triangle. I have an x of 1, a y of negative radical 3, and an r of 2. Now, they want me to find the sine of this guy. Then I look to the outside. Then they want a restricted angle who has the same sine as this angle. So yes, I need to find the sine of it. So what is the sine in an unrestricted angle? Right here, it doesn't really matter. What is the sine of this guy? Negative y over r, negative radical 3 over 2. Agree? So I replace that in here. So now I bring this down. So now I say, find me a restricted angle whose sine is negative radical 3 over 2. Well, am I in the right quadrant? Am I where sine is restricted to negative? Right, I'm in the right quadrant, but I have to find this angle in my restricted sine domain. My restricted sine domain is negative pi over 2 to pi over 2. So now, how will I call that angle in a restricted situation? I can't say 5 pi over 3 because it's out of my restricted domain. So, Manesh. Pi over 3 would put me over here in quadrant 1. You're on the right track.
Pi over -3.
A negative pi over 3. So is a negative pi over 3 the same angle? I am in the same triangle. So my problem is renaming these. I have to rename this a little bit.
And how did you rename the negative pi over 3?
Because in my restricted sign can only be restricted to 1 and to 2 and to 4, and it goes from negative pi over 2 to positive pi over 2. So an angle of 5 pi over 3 does not fit in here. So I need this guy, negative pi over 3. Now, it doesn't always work out this nicely. Let's keep this one. I keep wanting to switch my pen, and I keep forgetting to turn on my smart thing. So let's switch this. I'm going to switch this and say arc cosine of this. And let's see what happens. I started at the right. I've got the same triangle. I come all the way around. It comes all the way around. There's no restriction here. This is a 60-degree angle. I label all my parts. I'm good so far, right? I find the sign. The sign is negative radical 3 over 2. Now, I go to the right. I say, find me a restricted cosine angle whose cosine is negative radical 3 over 2. So I have to ask myself, where is cosine restricted? What quadrant?
0 and pi over 2.
So it goes from 1 to 2. I'm restricted from 0 to 180, right? If you think of your cosine curve, like I cut it here, I cut it here. There's the 90 in 1, and see the negative in 2. So now I cannot use this quadrant. My cosine curve is restricted to quadrant 2. It is the same exact triangle that I want in quadrant 2. But now I have to name it from 0 to pi, because that's where my cosine is restricted. So from 0 to pi, let's go back to the 3 pi over 3 and the 6 pi over 3. How would I name this angle starting from the 0? So what's 1 before 3? 2 pi over 3. Okay. Do you see the difference? Take a minute and digest this. When we say, look at this piece first. No restriction. So we locate the sign, we locate it in quadrant 4. We take whatever this is, we plug it into here. Now I'm just going to ask you, arc sine, negative radical 3 over 2. Where is it negative? Oh, it's negative in quadrant 4 already. I just so happen to have it in quadrant 4. So find me that angle. When I put arc cosine, I say cosine is restricted to 1 and 2, negative and 2. I now have to put that triangle in quadrant 2. Cosine is not restricted to 1 and 4, it's restricted to 1 and 2. Okay? Silence is not golden in here. You're very silent. Okay? All right. Let's take a look at this. I take a look at the right-hand side. What is this asking me to find? I'm sorry?
Arc cosine of pi.
Arc. I want an angle whose cosine is pi. Did I skip one? No, okay. This is a weird one to look at, right guys? An arc cosine, I can write it like that, of pi. I want an angle a restricted angle whose cosine is pi. Little different to look at that. What is pi worth? What is the value of pi? 180 degrees or 3.14. Do I have any angle whose cosine is 3.14? No solution. It's kind of a silly one to put in there, but one that I just wanted to show you. You're not really asking for an angle whose angle is this. You're asking for an angle whose cosine is this. So now it doesn't become pi. It becomes 3.14. My range of cosine is just -1 to +1. It was just a corny one to throw in there, I guess. Okay, so let's evaluate some of these guys. I go to the right. I follow order of operations. Order of operations says go to those parentheses, and I always start at the right. So, our cosine of 2/3. What is it asking me to find? Good, very good. A restricted angle whose cosine is 2/3. So I think about my restricted cosine curve. Where am I restricted to for cosine? 1 and 2. Out of 1 and 2, where is it positive? 1. So this brings me to drop a triangle in quadrant 1 because I'm restricted to 1 and 2, positive in 1, negative in 2. I say x over r. Okay? Now, I normally would have to find the angle for this, but there's more to this. So rather than go through trying to find the angle, I see what else did they want for this. So I look to this using this triangle. I say, what is the tangent of this angle? So tangent, I'm right where I need to be, is y over x. But I don't have a y. So how do I find the y? Pythagorean theorem. So I get 9, and I get y is equal to radical 5. So now I say, okay, tangent is my radical 5 over 2. Oops, I wrote radical 3. My radical 5 over 2. That's what this whole entire thing is equal to. And aren't I positive in quadrant 1? Sometimes we're looking for an angle. Sometimes we're looking for a ratio for my final one. So you have to decide that. Good so far? Okay, and the last one. Where do I start? Parentheses. I want a restricted angle whose sine is -3 over 5. So a restricted angle for sine, what quadrants am I restricted to?
1 and 4.
1 and 4. 1 is positive, 4 is negative. So what quadrant do I want? 4. So I label y over r. Can anybody find the missing sky? Yeah. Be careful. This is your hypotenuse. 5 squared equals 3 squared plus x squared. 4. Now, I've got my location. I want to see what they want. What do they want from this? They want the cosine of this particular triangle. So, what is the cosine for this guy? 4 over 5. And cosine in quadrant 4 is positive, right? 4 over 5. last one?
Yeah.
I want to just pick up your homework and see if there's a. Look at number 57 on your homework. This is the arc is on this side now. So I go to the parentheses. Do you have that? Okay. I go to the parentheses first. I say, what is the sign of 3 pi? Is there any restriction on this sign? I think no. So I'm not really sure exactly where 3 pi is, but I know this is 0. I know this is pi. I know this is 2 pi. Ah, I found 3 pi. So I'm still right here, right? What is the sign of 3 pi? Zero. So this guy is 0. So now I'm replacing that with a 0. I want arc sine of 0. I want a restricted sine angle. This time I want the angle. Give me the angle whose restricted sine is 0. So now, where is sine restricted to what quadrants? 1 and 4. Now, sines that have 1s and 0s and negative 1s and 0s come off my quadrants. So sine is my y. Oh, what value is that? What value is that? What angle has a restricted sine of 0? What angle has a restricted sine of 0? What angle is this guy right here? 0. 0 degrees, 0 radians. It always throws everybody off when we're looking for the value of 0 and the angle of 0. So do you see what this one did? It had you first find the value, and then when you went to the outside, you had to actually find the angle. Now, the first 3, you can just pick up your calculator and do it. Just because I wanted you to see, how do I find an angle whose sine is and an angle whose tangent is? How do we do that on your calculator? The first 3 are calculators. How do I find an angle whose sine is 0.45? Second, sine, 0.45. And it'll do a restricted angle for you.
For the calculator stuff, does that have to be in radian or?
Well, round to the nearest thousand, so probably radians. When it says round to the thousands, you're probably radians.
So there's thousands.
Yeah, there's thousands in degrees, but we don't usually say that. Second sign. Then just put that in.
I have 26.14.
Okay, so you're in degrees. So if you're in radians, you're going to get more of a decimal.
I am in degrees.
Okay, let's take a look at 59. Can we take a look at 59? I'm just trying to hit the ones like that are asking for the angles on the end. So I start with my parentheses, right? I have a little tangent. Tangent, no negative 1. So it's a regular angle. So it gives me 11 pi over 6. So I know this is 6 pi over 6. I know this is 12 pi over 6. So what quadrant do I find 11 pi over 6? 4. So I drop a triangle in 4. And how many times does 6 go into 180? 30, good. So I label 1, 2, radical 3. X is radical 3, y is negative 1, and r is 2. So I find the tangent for this guy. So what's my tangent? y over x negative 1 over radical 3. Good? I found the tangent just like they asked me to. So now I take it to the right. I say tangent negative 1 of negative 1 over radical 3. I want a restricted tangent, a restricted angle. And where is tangent restricted to? Which quadrants? 1 and 4. Where is it negative? 4. I just so happen to be in 4, don't I?
Mm-hmm.
So coincidentally, I'm in 4. But now I need to name this angle with my restriction. So what's my angle with my restriction? From negative 90 to positive 90. So pi over 6 would put me up here. Negative pi over 6. So I just so happen to be in the same place, but in my unrestricted tangent, I started from 0 and came all the way around. With my restricted tangent, I went from negative 90 to positive 90. So in your calculator, if you said this, the tangent of negative pi over 6, and then you put in the tangent of 11 pi over 6, they would both come out to say negative, whatever this is, 1 divided by this.
Wait, so once you're at the step of tangent equals negative 1 or negative 1 over radical 3, before you do the restricted, how do you do that?
Once you got this part, right?
Yeah.
So now, we replace this with that. We look at this, and we say, oh, it wants an angle, a restricted tangent angle, whose tangent is negative. Tangent is negative in 1 and 4. Oh, I just happen to be in 4, so I don't have to rewrite anything. If this said cosine negative 1, if it said cosine negative 1, what quadrant would I be in? I'd be in quadrant 2. I can't have that angle. It's not my special angle, but I would be in quadrant 2.
So how do you get negative pi over 6?
Because my restricted angle for tangent can only go from negative pi over 2 to positive pi over 2. So even though it's the same location, I have to name this with accordance to the restricted angles. So I have to now name this as a negative pi over 6. I can only go from negative pi over 2 to positive pi over 2 in my restriction. So I have to rename that. So if you check both of these, they would be the same solution, right? It's the same thing. It's just that how's another way to name this angle? Okay? So try these. Try what's left of them.